In this lesson, we're going to take a look at solving equations that have exponents in it, specifically something to the second power or squared. But I do want to start by going back and reviewing a little bit of what we've been doing to solve equations. We've been dealing with this idea of, it's technically called the inverse of something. The inverse basically is undoing or removing, or the opposite of it, so to speak, but not opposite in terms of negatives. So if I had an added number, we would do the opposite of it, or remove it, or the inverse of it. So we would add opposites. So that's called the additive inverse, when you add the opposite of a number to make it go away. It's the inverse operation of it. If I have multiply and I use the reciprocal, that's the multiply inverse. And we would multiply by reciprocals. So adding opposites ends up being the opposite of adding. It's the additive inverse. Multiply by reciprocals is the opposite, so to speak, of multiplying by a number. That's the multiplicative inverse or multiply inverse. What we want to do is take a look at what is the opposite of squaring something. So let's take a look at that. So let's take a look at the opposite of squaring something. Let's start simply with 8 squared. We know 8 squared is 64. Okay? So squaring goes this way. Now, how would you reverse that? How would you go backwards of that? What if you started with the number 64? And somebody asked you, okay, how do I get from a 64 down to an 8? The inverse of squaring something is called the square root. Square root, the symbol almost looks like a divide into. We go up, down, up, across. And it's got a little hook in the front, so this is the square root of 64 equals 8. The square root is saying what number times itself is this number. Okay? If I asked you for the square root of 25, what number times itself is 25? Well, it's the reverse of this. You would have to think, okay, what number squared is 25? Oh, well, you would say it's 5. So the square root of 25 is 5. The square root of 36 is 6. It's just the opposite of it, or the inverse of it. So let's take this idea of square rooting something to do the opposite of squaring and apply it to solving equations now. We're going to take a look at a few examples of solving an equation where the variable now is raised to the second power. So this equation simply says a number that is squared is equal to the value of 100. Now I know that we can decide, I know what m is. M has to be 10. What other number times itself is 100? Well, negative 10 actually, but let's just worry about positives for now. Now I get that we can get here, but I still need to show proof, or what algebra am I using to get this picture, m squared, to physically change into just the picture of m. So what we're going to do is we're going to do the opposite, or the inverse of what's happening to the m. Well, right now the m is being squared. So my step 1 is going to be to square root both sides. And it needs to happen to both sides because in an equation which is equal, if you do something to one side and don't do it to the other, then all of a sudden my seesaw or my balanced equation is not going to be balanced anymore. So if you do it to one side, you have to do the same thing to the other so it still remains balanced. So what would the work look like for this? Well, I would put a square root sign over this side. I would put a square root sign over this side. The square root and the 2 cross each other off. What's the only thing I'm left with over here? Is the m, and that's what I want. So the m gets rewritten here. If I square root this side, I square root this side, the square root of 100 is 10. Simple enough. M squared equals 81. Square root both sides. Square root, again it's both sides. Square root of m squared. Square root removes the exponent of 2, they're the inverse, they're the opposites. The only thing I have left on this side is the m. Square root of 81 we know is 9. Done. Let's take a look at this equation. Similar idea, I'm trying to remove everything that is with the m. I need to get rid of the exponent of 2. I need to get rid of an added 7. I want the m all by itself. Well, it's a good thing we know how to remove things. We have add opposites, multiply by reciprocals, and square root. So those become 3 tools to remove basically anything we need to. When we go to do this, I'm always trying to get rid of the added number first. Secondly, I would get rid of any multiplied numbers. Lastly, I would look to get rid of any exponents. So if you look at this, this is like reverse order of operations. But I'm going backwards, add, multiply, exponents. So let's take my equation and step one says get rid of the added number. So I'm going to take this and open it up. I'm going to add things to the side. M squared plus 7, that's my original. I'm going to leave space because I'm going to add a number in. 11 is on this side plus a number. Okay, what number am I adding to get rid of an added 7? I'm going to add its opposite, which is negative 7. If I do it to one side, I need to do it to the other. Why? So that my seesaw stays balanced. The right-hand side, 11 plus negative 7 is 4. The left side, 7 plus negative 7. By the way, these are the only 2 things I'm allowed to add up because they don't have a variable. These are common terms. Like terms. 7 plus negative 7 is 0. The only thing I have left on this side is m squared. So I bring that down here. Step 1 is done. Do I have any multiply? Some may say, yeah, you have multiply. That's what exponents does. But in this case, I don't have a multiplied number to get rid of. Exponents. I do have exponents. How do I get rid of exponents? Square root both sides. Square root. Does it go over both sides, Mr. Long? It should, because I want my equation to stay balanced. The square root symbol removes the exponent of 2. All I have left is the m. Square root of 4 we know is 2. Done. Let's look at one more. Let's take a look at this last equation. 4 times a number squared minus 18 equals 238. Now if we go through our steps and get rid of add, then multiply, then exponents, we should be able to figure out what the missing number is. That when I square it and times by 4 and minus 18 gets me 238. Think about it. What number times itself times 4 minus 18 is 238? Now I'm sure if you thought long enough you would be able to figure it out, but with solving it gets us there faster. It's a strategic approach to remove and eliminate and whittle it down to figure out m must be this. And you're already thinking, okay, well if this is minus 18, I'm going to add 18 over there. That's adding opposites. When this is times by 4, so I'm going to divide by 4. Although we're not dividing by 4 this year, we're using multiply by the reciprocal. Why? Because it will help us in algebra when we get there. I know it's the same concept. Multiply by 1 over 4 is the same as dividing by 4. Just trust me, if we can write times by 1/4, use our calculator, it will help us in the long run. Here we go. Very first thing to do, always take any subtraction, turn to addition. This becomes plus the opposite of what follows it. So the term that follows it is an 18. I want the opposite of 18. I want to remove the added number first. So I have 4m squared plus negative 18. I'm going to drop in an added number. On this side, I'm going to drop in the same added number. Okay, I need the opposite of negative 18. Should be 18. On this side, Same thing. So let's combine like terms. Oh, this is negative 18 plus positive 18, which is 0. The only thing I have left is 4 times m to the second. This becomes 4 times m to the second. On this side, I have 238 plus 18. Take my calculator to speed it up. 238 plus 18 gives me 256. So now I have 256. Step 1, done. Can I now multiply by the reciprocal of the multiplied number? Sure, this term has a multiplied 4. So I want the reciprocal of that. Reciprocal of 4 over 1 is 1 over 4. Multiply this side by 1 over 4. The 4's will cancel. All I'm left with now is the m to the second power. So I have m to the second power equals, I need 256 times 1/4. Luckily, the 256 is still in my calculator. So I take 256 times 1 over 4. Let my calculator do all the fraction work. And I end up with 64. I'm sure by now you can see where this is leading to. My last step is to take care of any exponents. Okay, this is something to the second power. By the way, I finally got it down just to the m. I got rid of the multiplied, I got rid of the added number. How do I get rid of an exponent of 2? Square root. If I do it to one side, I do it to the other. The square root symbol removes the exponent of 2. The only thing I have left is the m. Square root of 64 is 8. Done. So just remember that when you have a variable with an exponent of 2, the square root symbol is the thing that will remove it. Just like adding opposites gets rid of an added number, multiplying by reciprocals gets rid of the multiplied number. Whew, that's a lot. Good luck.